Hello viewers, I Neela from Jamia Millia Islamia welcomes you to the chapter of integration and applications of integration. In this script, we'll discuss the concept of integration. Integration helps us to find total functions from marginal function. It also helps us to find measures of total revenue, total variable cost, consumer surplus, producer surplus, etc. It is the inverse or reverse process of differentiation. If d by dx of fx is equal to capital Fx, then integration of fx dx is equal to fx plus c. These integrals are called indefinite integrals or generally integrals. Integration problems are involved in various scientific formula and results. We'll discuss the definite and indefinite integrals in various examples. So in this script, we'll study about the integration and its application by using its standard formulas. Let's begin with the concept of integration first. When we differentiate a function fx with respect to x, we get another function as a result of it. Let d by dx f of x is equal to fx. Integration helps us to find total functions from marginal function. It also helps us to find measures of total revenue, total variable cost, consumer surplus, producer surplus, etc. It is the inverse or the reverse process of differentiation. If d by dx of fx is equal to capital Fx, then integration of f of x dx is equal to fx plus c. These integrals are called indefinite integrals or general integrals. C is called the constant of integration and fx is called the integrand. All these integrals differ by a constant. Let's see an example here. Evaluate the following integrals. First one, integration of 3x square plus 2e to the power 2x of dx. Second, integration of x square minus 1 the whole to the power 2 dx. Third, integration of x to the power 5 dx. Let's see the solution one by one. Integration of 3x square plus 2e to the power 2x of dx is equal to integration of 3x square dx plus integration of 2e to the power 2x dx. So that is equal to 3 times integration of x square dx plus 2 times integration of e to the power 2x dx. So that is equal to 3 times x to the power 2 plus 1 by 2 plus 1 plus 2 times e to the power 2x by 2 plus c. So that is equal to x to the power 3 plus e to the power 2x plus c, where c is an arbitrary constant. Second, integration of x to the power 2 minus 1 the whole to the power 2. dx. So this is the integration of x to the power 4 minus 2x square plus 1 dx. So that is the integration of x to the power 4 dx minus 2 times x to the power 2 dx plus integration of 1 dx plus c. So that is equals to x to the power 4 plus 1 by 4 plus 1 minus 2 times x to the power 2 plus 1 by 2 plus 1 plus x to the power 0 plus 1 by 0 plus 1 plus c. So that gives us 1 by 5 times x to the power 5 minus 2 by 3 times x to the power 3 plus x plus c. Third, integration of x to the power 5 dx is equal to x to the power 5 plus 1 by 5 plus 1, which is equal to 1 by 6 times x to the power 6 plus c. Let's see another example. If f dash x is equal to 3x square plus 2 and f of 0 is equal to 0, then find f of 2. Let's see the solution. We are given f dash x equals to 3x square plus 2. That is, d by dx of fx will be 3x square plus 2. So that implies f of x is equal to integration of 3x square plus 2 dx, that is equal to 3x cube by 3 plus 2x plus c. So that is, function fx will be equal to x to the power 3 plus 2x plus c. Now when x is equal to 0, f of 0 will be 0. Now this gives 0 equals to 0 plus c, or c is equal to 0. This implies f of x is equal to x to the power 3 plus 2x. Hence f of 2 will be equal to 2 to the power 3 plus 2 times 2 is equal to 8 plus 4, which is equal to 12. In the above section, we have discussed integrals of those functions which were readily obtained from derivatives of some functions. It depends on inspection or knowledge of standard integrals. However, it is not very suitable for many functions. In such cases, we need to develop additional techniques or methods for finding the integral by reducing them into standard forms. Given below are 3 such methods of integration. First one, integration by substitution. Second, integration by parts. Third, integration by partial fractions. In this section, by suitable substitution, the variable in the integrand is changed into another variable so that the integrand gets changed into a function which can be easily integrated. The given integral, integration of fx dx, can be transformed into another form by changing the independent variable x to t by substituting x equals to g of t. Now consider I equals to integration is equal to integration of fx of dx. Put x equals to g of t so that dx by dt is equal to d dash t. We write dx is equal to g dash t dt. Thus integration I is equal to integration of fx dx is equal to integration of f of g of t times g dash t dt. Now let's see the example for this. Integrate the following function with respect to x. First one, cos mx. Second, 2 times sine x square plus 1. Third, sine of tan inverse x by 1 plus x square. Let's see the solution one by one. For the first one, we know that the derivative of mx is m. Thus we make the substitution mx equals to t, so that m dx is equal to dt. Therefore, integration of cos mx dx is equal to 1 by m integration of cos t dt. That is equal to 1 by m integration of cos t dt. So this is equal to 1 by m times sine of t plus c, which is equal to 1 by m sine mx plus c. Let's see the second one. Now the derivative of x square plus 1 is 2x. Thus we use the substitution x square plus 1 equals to t, so that 2x times dx is equal to dt. Therefore integration of 2x times sine x square plus 1 dx is equal to integration of sine t dt, which is equal to minus cos t plus c. So this is equal to minus cos of x square plus 1 plus c. Let's see the third one. Derivative of tan inverse x equals to 1 by 1 plus x square. Thus we use the substitution tan inverse x equals to t, so that dx by 1 plus x square is equal to dt. Therefore, integration of sine of tan inverse x by 1 plus x square dx is equal to integration of sine of t dx equals to minus cos t plus c, which is equal to minus cos of tan inverse x plus c. Now we discuss some important integrals involving trigonometric functions and their standard integral substitution technique. First, integration of tan x dx is equal to log of absolute sec x plus c. Integration of cot x dx is equal to log of absolute sin x plus c. Third, integration of sec x dx is equal to log of absolute sec x plus tan x plus c. Fourth, integration of cosec x dx is equal to log of absolute cosec x minus cot x plus c. In this section, we integrate the function that is found quite useful in integrating products of functions. This process of integration of the product of two functions is known as integration by parts. If u of x and v of x are two functions such that first ux is a differentiable, second v of x is integrable, then integration of u of x times v of x dx will be equal to u of x times integration of v of x dx minus integration of d by dx of u of x times integration of v of x dx. The whole is integrated as dx. That is, integral of the product of the two function is first function times integral of the second function minus integral of differential coefficient of the first function times integral of second function. But if the integrand is the product of two different types of functions, choose the first function which comes first according to ILATE. Here I stands for inverse trigonometric, L stands for logarithmic, A stands for algebraic arithmetic, T stands for trigonometric, E stands for exponential. We'll see example here. Evaluate first integration of x square times e to the power 2x dx, second integration of log x dx, third integration of x times log x dx. Let's see the solution one by one. For the first one, taking x square as a first function and e to the power 2x as a second function. So let's do the integration of x square times e to the power 2x dx. This is equal to x to the power 2 times integration of e to the power 2x dx minus integration of d by dx x square times integration of e to the power 2x dx times dx. The whole thing is integrated. So this is equal to x square times e to the power 2x by 2 minus 2 times integration of x e to the power 2x by 2 dx, that is equal to x square times e to the power 2x by 2 minus integration of x e to the power 2x by dx. This is equal to x square e to the power 2x by 2 minus, the whole thing is in bracket, that is x integration of e to the power 2x dx minus integration of d by dx of x times dx, and the whole thing is integrated. So this is equal to x square times e to the power 2x by 2 minus x times e to the power 2x by 2 plus 1 by 2 times e integration of e to the power 2x by dx. This is equal to x to the power 2 times e to the power 2x by 2 minus x times e to the power 2x by 2 plus 1 by 4 times e to the power 2x. That is equal to e to the power 2x by 2 In bracket we have x to the power 2 minus x plus 1 by 2. Let's see the next one, the second one's integration of log x dx. So this is equal to log of x 0.1 dx. That is equal to log of x integration of 1 dx minus integration of, in bracket, d by dx of log of x times integration of 1 dx times dx. So this is equal to x times log of x minus integration of 1 by x times x dx plus c. That is equal to x log of x minus integration of 1 dx plus c. This is equal to x log of x minus x plus c. So that equals to x times log of x minus 1 plus c. Let's see the third one, integration of x times log of x dx. So this is equal to log of x times integration of x dx minus integration of, in bracket we have d by dx log of x times integration of x dx times dx. This is equal to x to the power 2 by 2 times log of x minus 1 by 2 times integration of 1 by x times x to the power 2 dx plus c. That equals to x to the power 2 by 2 times log of x minus 1 by 2 times x square by 2 plus c. That is equal to x to the power 2 by 2 log of x minus x to the power 2 by 4 plus c. That gives us finally x to the power 2 by 2. In bracket we have log of x minus 1 by 2 plus c. First, integration of dx by x square minus a square. So that is equal to 1 by 2a log of absolute x minus a by x plus a plus c. Second, integration of dx by a square minus x square is equal to 1 by 2a log of an absolute a plus x by a minus x plus c. Third, integration of dx by under root x square plus minus a square. So this is equal to log of x plus under root x square plus minus a square plus c. Fourth one, integration of under root x square plus minus a square dx is equal to x by 2 times under root x square plus minus a square plus minus a square by 2 times log of x plus under root x square plus minus a square plus c. In this section, a rational expression in which denominator can be factorized can be integrated by breaking the integrand as a sum of simple rational functions. In this method, integration function is in the form of f of x by g of x, where both f of x and g of x are polynomials and f of x is of lower degree than g of x. Such functions are called rational functions. We break up the rational functions into partial fractions to obtain the integral of f of x by g of x and then integrate each term separately. Partial fractions for some standard functions are as follows. So let's take an example. Evaluate integration of 3x square plus 5x by x minus 1 times x plus 1 to the power 2 of dx. Let's see the solution. 3x square plus 5x by x minus 1 times x plus 1 to the power 2 is equal to a by x minus 1 plus b by x plus 1 plus c by x plus 1 to the power 2. This gives 3x square plus 5x is equal to a times x plus 1 to the power 2 plus b times x plus 4 times x minus 1 plus c times x minus 1. Substituting x equals to 1 and x equals to minus 1 successively in this equation, we get 8 is equal to a times 4 and minus 2 equals to c times minus 2, or a equals to 2 and c equals to 1. Now equating now the coefficients of x square on both sides of the above equation, we get 3 equals to a plus b, or b equals to 3 minus a, that is equal to 3 minus 2, which is equal to 1. Now since a is equal to 2, so we have 3x to the power 2 plus 5x by x minus 1 times x plus 1 to the power 2 will be equal to 2 by x minus 1 plus 1 by x plus 1 plus 1 by x plus 1 square. Hence, integration of 3x square plus 5x divided by x minus 1 times x plus 1 to the power 2 dx will be equal to 2 times integration of dx by x minus 1 plus integration of dx by x plus 1 plus integration of dx by x plus 1 to the power 2. That is equal to 2 times log of x minus 1 plus log of x plus 1 minus 1 by x plus 1 plus c. So that equals to log of x plus 1 times x minus 1 to the power 2 minus 1 by x plus 1 plus c. If f of x is a continuous function on a closed interval a, b, let integration of f of x dx is equal to capital F of x. The definite integral of f of x over the interval ab is defined as integration from a to b of f of x dx is equal to capital F of x going from a to b. So that implies f of b minus f of a, where a is the lower limit and b is the upper limit of the integral. We'll see one example. Evaluate integration goes from 2 to 3 of 5x plus 2 of dx. So we'll see the solution. Let I equals to integration goes from 3 to 2 of 5x plus 2 dx. So that is equal to 5x square by 2 plus 2x. It's going from 2 to 3. So that is equal to 5 of 3 to the power 2 by 2 plus 2 times 3 minus 5 of 2 to the power 2 by 2 plus 2 times 2. So that is equal to 45 by 2 plus 6 minus 20 by 2 plus 4, which is giving us 69 by 2 minus 14, that is equal to 41 by 2. Let's see another example. Evaluate integration goes from 0 to 1 of sine inverse x dx. Let's see the solution. Let I equals to integration goes from 0 to 1 of sine inverse x of dx. So let I1 be equal to integration of sine inverse x dx. Now put x equals to sine theta, x equals to 1, so that implies theta equals to pi by 2, and x equals to 0, that implies theta equals to 0. So that means dx is equal to cos of theta d theta. Now I1 is equal to integration of sine inverse sine theta cos theta d theta, that is equal to integration of theta times cos theta d theta, that is equal to theta times sine theta minus integration of 1 times sine theta d theta, that is equal to theta times sine theta plus cos theta. So I equals to theta times sine theta plus cos theta, and this whole thing is going from 0 to pi by 2, that is equal to pi by 2 times sine pi by 2 plus cos pi by 2 minus 0 plus cos of 0, that is equal to pi by 2 minus 1. Integration has a wide range of applications of definite integral problems, or in the form of applications to business and economics problems. Some are discussed as: first one, total cost of x units is given as C of x, capital C of x, which is equal to integration goes from 0 to x of marginal cost dx, and average cost AC is equal to total cost by x, which is equal to C of x by x. Second, total revenue of x units sold is given as capital R of x. So this is equal to integration goes from 0 to x marginal revenue dx, and average revenue AR is equal to total revenue by x, so that is capital R of x by x. We have already discussed that R is equal to Px, where P is the price and X is the total output when the total revenue is the demand function. Then P is equal to R by X. The third one, for maximum profit, if marginal revenue and marginal cost functions are given, then P, capital P is equal to capital R minus capital C. Now differentiating with respect to X, we get dP by dx equals to d of dx of R minus C, that is equal to dr by dx minus dc by dx, which is equal to marginal revenue minus marginal cost, mr minus mc. Now integrating with respect to x, we get P will be equal to integration of dp by dx, that is equal to integration of mr minus mc dx plus k. Fourth, if I of x is the inventory on hand and HC is the cost of holding 1 unit, then for time period capital T, total inventory carrying cost will be equal to HC times integration goes from 0 to T of I of x dx. Fifth, if marginal propensity to consume is given, then find consumption function. So we have C of x obtained by integrating the marginal propensity with respect to Y income. Now consumption function, that is C of x, is equal to the integration of dc by dy. Let's see an example. Find the cost function if the marginal cost of the production is to be found. Now marginal cost function is given as 1800 minus 40x plus 3x square, where x is the number of units produced. The fixed cost of production is rupees 2000. Let's see the solution. MC is given as 1800 minus 40x plus 3x square. So total cost C will be equal to integration of 1800 minus 40x plus 3x square dx, that is equal to 1800x minus 40x square by 2 plus 3x cube by 3 plus k. Let's make this equation 1. Now total cost at x equals to 0 is 2000. Now put C is equal to 2000 and x equals to 0 in equation 1. We get 2000 equals to k. So let's make this equation 2. Now from equation 1 and 2, cost of x, that is C of x, is equal to 1800x minus 20x square plus x cube plus 2000. Let's see another example. Find the revenue function if a firm's marginal revenue function is given as MR equals to 20e to the power minus x by 10 times 1 minus x by 10. Let's see the solution. Integrating the marginal function with respect to x, we get R equals to integration of 20 times e to the power minus x by 10 times 1 minus x by 10 dx, that is equal to 20 times integration of e to the power minus x by 10 dx minus 2 times integration of x e to the power minus x by 10 dx, which is equal to 20 integration of e to the power minus x by 10 dx minus 2 times, in bracket we have minus 10 x e to the power minus x by 10 plus 10 times integration of x times e to the power minus x by 10 dx plus k. So that equals to 20x e to the power minus x by 10 plus k. Now when r is equal to 0 and k is equal to 0, and therefore the revenue function is r equals to 20 times x times e to the power minus x by 10. Okay, now let's take the next example. Marginal propensity to consumption function is given as dc by dy, which is equal to 0.5 minus 0.001y, where C is a consumption and Y is a disposable income. Find the total consumption if consumption is 0.2 when there is no income. Now let's see the solution. We have dC by dy given as 0.5 minus 0.001y. Now integrating with respect to y, cy is equal to integration of 0.5 minus 0.001 dy. That is equal to 0.5y minus 0.001y square by 2 plus k. Now when y is equal to 0, c of 0 will be equal to 0.2. Therefore k is equal to 0.2. Hence c of y is equal to 0.2 plus 0.5 times y minus 0.0005y square. So finally we have learned today integration and its application. We have also learned how to find the integral by using its various formulas which depends on the given functions. We have discussed marginal cost functions and how to define cost function when marginal cost is given. We have also discussed how to find revenue function when marginal revenue is given. So that brings us to the end of today's episode. We're ending here and we'll see you again discussing about on next topics on mathematical finance and their application to business and economics. Till then, have a nice time. Thank you and bye.